Yes, in this example, we have a problem of equilateral triangle. That's mean the distance between the three wires, they form a triangle, and the distance is the same. That's mean it's 4 centimeter distance apart. The X on this paper, it shows that it's going into the page, and on top here, if you see a dot, that means it's out of the page. So the current is going to be out of the page. To measure the currents, we have a way to do it, and then we can use the forces that affect this wire here. So the first, we know that they have the same mass, and they have the same current. So we don't need to look hard for this. So the mass for each is 0.05 kilogram. The length is 1 meter. The current of 1 is going to equal the current of 2 is going to equal of the current I3. And the distance between all of them is 0.04 meter. So on the first one, we're going to measure the forces that acts on the top one that coming out from the page, and the angle is 30 degrees on each. This is the force of the magnetism that affects from the bottom, and we have a magnetic gravitational force that it's affecting the wire down. So we know that the force of the first two of the cosine 30, because we have two wires that is going affecting the upper one, minus the gravitational force of that wire. And then we're going to find the total force. So the first one is going to equal the mass acceleration cosine 30. Oh, come on. And this one is going to equal 0.05 kilogram multiplied by 9.8 meters second multiplied by cosine 30. So the force here is going to be equal to 0.42 Newton. And this one, we're going to multiply it by 2 because we have two wires that affected the upper one. And this is 0.85 Newton. And then we know that the one plus the 2 minus the 3. So 0.85 Newton minus 0.49. 0.42. And this one will give us, sorry, 0.49. 0.49. Just to give you, multiply by 9. 0.49. Because of the force gravitational is equal to 0.05 multiplied by 9.8, and this one is equal to 0.049. And the total force on the wire is 0.36. So we're going to use this formula here, equal I length B. We know that the B equal the permeability constant multiplied by I divided by 2 pi d distance. We're just going to replace this one with this, and it's going to give us force equal I square length permeability constant divided by 2 pi distance. So 0.36 equal I square length permeability constant divided by 2 pi 0.04. The current will be 268 amp.